Hey, what's going on, folks? It's Mike here, and today we're going to be doing a little bit of a fresh impression of the Go programming language. I'm going to be doing this for a few different programming languages because folks have said, Mike, you've got to learn this language, and I've always been curious myself about different programming languages, how they do different features, and sometimes looking at a programming language and learning their specialty will help you in another language as well. So Go in particular, I know, is great for concurrency. That's how it's sort of designed, but it's also a tiny enough language that folks claim that it can be learned relatively quickly. So with that claim, let's go ahead and take a look at the Go programming language. I'm going to go ahead and just start from the website here. And again, I don't know anything. I've never written a line of Go code in my life here, so we're just going to go through this, and folks in the comments can correct me, put a timestamp if I mess something up. But Go is a language I think is originally developed by Google, and now it looks like it's open source, or maybe there's a foundation or something that manages it, so that it's not just solely run by Google. I know a lot of different startups that use Go, for instance, for their backend services. So it has gained some popularity over the years of its existence. Again, the claim that it's easy to learn, we'll see, but it is supposed to be a relatively small language. I believe it was designed by Rob Pike and Ken Thompson, who's involved with C. So, they're great programmers in their own respects and have probably put a lot of thought into this. And the concurrency, yeah, that is the big thing here. So we'll go ahead and take a look at that. And yeah, if it's got a good standard library, that's great. I like to have everything in the standard library as opposed to, too many third-party dependencies. Good tooling, I'm sold if that's the case here. So let's go ahead and just take a look. Yeah, there's a lot of big companies here using it, some gaming companies, etc. Okay, so yeah, it's been adopted quite well. I've got some nice claims here. And here's your hello world, which is great. Always like running these things. And there's a tour here. Let's open up that tour. We'll probably want to go through that in a little bit here. Oh yeah, cool. It looks like there's like Unicode, just handles these, different non-ASCII strings. That's something I haven't had to wrestle with too much, but as soon as you start supporting multiple languages and internationalization and these types of things, that can be a little bit messy. So that's kind of cool. Let's see what else here. Okay, cool. Web dev stuff. Yeah, command line, cloud tools, other stuff. Okay, lots of different use cases. Yeah, let's go ahead and get started. Let's download Go here. I'm on Linux. Let's see how easy that is to do. Now I'm sure I can just open up a terminal and run it here. I'm just going to download here, and I'm just looking with you. Okay, Go 1.13 downloads a bunch of the stuff. Okay, what does that mean here? Now I'm on Linux, so it looks like I'm just going to download this tar file here. Okay, so that's going to go to my downloads folder. And let's see, instructions. I guess we're building from source here. What did I download here? Installing Go from source. I might end up just using my package manager. We'll see what happens here. But okay, we have some instructions here. Let's just copy these. Okay, so let's go to downloads. And let's make this a little bit smaller here. Okay, we'll do that. Permission denied. Okay. Well, usually when you get those things, here we are. Sudo. Sure. Install whatever. Cannot open no such file. I know why. Actually, let's see here. Okay. I've never installed Go, so that's probably why I don't need this stuff. Nothing to remove. Let's see here. Tar. Okay, -C. I'll have to look up that argument. Okay, this is installing basically Go in my local folder here. Let's see if that does the trick here. Okay, so maybe it did something. Okay. And then I need to export this path here. Okay. Now let's see if it actually installed it. If I go to user, local, Go, bin. Okay, I've got a Go compiler here. Cool. Oh, okay, something's working here. I will add this on my path. That seems fine. Here, I'll click that here. Okay, so pretty easy install here. If you're a Linux user, that's not too bad. I'm sure you could probably just do like sudo apt-get and install Go, but I want the latest and greatest. Let's see what our Go version is. Okay, yeah, 1.21. That's not too bad. Pretty clean. I actually don't mind installing stuff this way. Um, because then I can have multiple versions or not have multiple versions, and that's pretty good. Okay, so so far so good. Yeah, that was way less than 10 minutes here. Okay. Oh, this is the getting started tutorial. Let's see if that's the same thing as the tour. Okay, we got our prereqs here. Okay, yeah, we do have some programming experience, a terminal. Okay, let's go ahead and write our hello world here. Okay, enable dependency tracking for your code. Okay, so first let's go ahead and follow the directions properly. Let's make a directory called go code here. I'll make this a little bit larger. And let's go ahead and make our directory hello. I'm going to go ahead and split the window here. I'm just going to do this all in Vim. I won't get to explore the tooling as much, like if there's a great IDE or something. Maybe folks can let me know in the comments and we can take a look at that. But let's go into a hello directory. Let's do that here. And let's see, enable dependency tracking of your code. Okay, so when I import packages containing other modules, let's see. Okay, you manage those dependencies through your own, through your code's own module. That module is defined by a go.mod file that tracks the modules that provide these packages. Okay, that go.mod file stays with your code, including in your source code repository. Interesting. Okay. To enable dependency tracking for your code, I create this file and then, create the init command or something. Okay. Interesting. This is kind of different for a getting started tutorial. If I'm a true beginning programmer, I probably don't care about this stuff. I probably don't even care about this right now. This sounds like it's interesting though. I wonder if this is so that when I build a package, I can specify what version it is, or if I have dependencies, what versions it's using. In that case, that's probably super useful for like large projects. Says for the purpose of this tutorial, just use example/hello. Okay. Go mod. Oh, this is just initiating a module for me. I see. Okay. I don't know what this other stuff is. Okay, we're in our hello directory. Go. Let's actually just do something even simpler here. Let's just type in go for a second and see at the command line what different tools we get here. Okay, cool. So Go is a tool for managing Go source code. Okay, it's like the compiler. But it also looks like there's a build system here. Okay, just doing build. There's a documentation engine here, maybe. Okay. I can list out packages or modules. Module maintenance. Interesting. Compile and run the program. Maybe run some tests here. And report likely mistakes in packages. Interesting. And then go version. Okay. Cool here. Additional help topics. Okay, so they've really thought out this command line tool. Seems pretty neat here. Okay, so go mod init example/hello. Let's just type out their example. Okay. So that made this thing here. Okay, so this tells me what version of Go I'm using and a module name. Okay. So in my text editor, create a file hello.go. Okay. Hello. And I wonder, let's go ahead and print this out. Hello.go. Okay. I'm just trying to figure out if there's like a hierarchy of files, but this just tell me hello.go. Okay, I'll just do that there. Okay, package, main, import. This is from our standard library. And our main function, which is the entry point in our program. And print line here. Hello world. Okay. And no semicolons at the end. Okay, that's kind of neat here. So let's see what we're doing here. Declare main package. Okay, so that's how we're grouping our functions together. I wonder if I can do this across different source files if I have multiple. The import a package, FMT, which has a bunch of these functions. Okay. And this is from our standard library. Okay. And those things are just built into Go. Okay. And then our main function here. Okay. Main's executed by default. Yep, makes sense. Okay, save it. Go, run. I'm going to omit the period here. Let's see what happens here. No Go files listed. Okay, so if I just do dot, does that find every Go file. Looks like it does. Okay, pretty good. Compiled and ran. I wonder if I run it again. Yeah, it runs lightning fast. No changes. So again, it must be modifying that system, or somehow managing or maybe caching some of the files behind the scenes. That's very cool. Okay, let's call code in an external package. Okay, from somebody else here. Okay. This is showing how to make our stuff a little bit more interesting. Visit package.go.dev here. Okay. This is kind of cool here. Oh, we just have a bunch of packages. This is good. This is like the D language also has a central repository. I'll be comparing languages as I go through this, just because it's kind of neat here. And which one do they want me to search for? Locate rsc.io quote package. Okay. I can do that. Let's paste that in here. Okay. Oh, found it. Okay. What does this do? Okay, it's got a readme here. This package collects pithy sayings. Okay. Glasgow, hello. Okay, it's got some nice documentation here. Okay, return types, trailing return types on functions. We'll get into the actual language here. It's kind of neat here. But let's actually get this running here. Okay, so I located that package in the documentation section using index. Note the functions you can call from the code. Okay, that was these things here. Let's go index. There we are. So that's what that package will give us. At the top of this package, note that package quotes is included in the rsc.io quote module. Okay. So if I want to import this, this is really nice. Modern languages, you know, I just imported in here. That's really nice. Okay. Let's paste it in here, see what happens. Let's do go run without any changes. It says no required module provide package. To add it, go git. Okay. Go git rsc.io/quote. Okay, I downloaded it. Now one thing, let's see here. Let's clear this out here. I've got this new go sum file. Okay, what's that? Okay, interesting. Let's see if this tells me what's going on here. Go will add the quote module as a requirement. Oh, I might have skipped a direction here. As well as the go.sum file for authenticating the module. Okay, cool. So we make sure it's the right module, and then we do go run. Okay, so let's actually go ahead and try this stuff here. Let's do hello world and quote. Okay, that's our package here. .go. Actually liking not having to type out a semicolon. Let's go ahead and run here. Okay, don't communicate by sharing memory. Share memory by communicating. Ha, funny. Go. Let's try glass. Okay. Go proverbs. Interesting. Let's give me a new proverb every time. Okay. Go glass. One more here. I can eat glass and it doesn't hurt me. Uh-oh. Okay. Very funny. Okay, so this is interesting. This little quick start here. Kind of cool to see how to create some of the modules here. I like this website already with different tutorials here. This is very thoughtful. And it looks like you can get to pretty quickly developing a RESTful API with Go and this Gin web framework. Okay, cool. I'll be curious to see which of these frameworks are like super well supported, if packages in Go tend to stick around, you know, so the quality of things. Do they have tests? Actually, I saw that was a Go test here. Yeah, no test files, but that's kind of cool here. It looks like that's just kind of built in. Maybe we'll get to that. So let's go ahead and just see on the tour of Go some of these features of the language here. And again, I like when languages have these like tours that you can do. That makes things super, super nice for new folks like me. So again, if I just go to welcome here, okay, we've got our hello world, which we looked at, different languages, awesome. And we do this offline. Ooh, I really like that because when I'm on a long airplane ride, that's something that's just really thoughtful to be able to run the tour as needed. Okay, playground here. Cool. So let's just add some packages. And some of these things are, uh, sometimes taken for granted, but like having a good time package, time and date. Let's see, how do we use this? So format, print line, time dot now. Okay. You folks want to see how late I am programming? There you go. It's 11 o'clock my time in the Eastern time zone. Okay, cool. Get to UTC time here. One thing I want to do here too is let's just go to the Go programming language page here. The docs and the standard library. So I've just added in time. Let's see, is that easy to find? Time. Okay, time.now. Okay, yeah, the index, this is pretty clean. I mean, it's just, there's a type and then a bunch of functions here. Interesting. And just some free functions here for sleeping. Let's just try that out. I'm going to sleep for a duration. Ooh, and I like this too. There's examples. So I can know time.second. Okay. So let's do hello world. Line. Time dot sleep, was it? Let's see here. Yep, I think that was it. Now these functions are all uppercase. That's what I was looking for. Sleep, and then I gotta specify the time dot second or something. Let's see if that worked. No value. Oh, okay. Is this a function or something? Let's see if that works. And then let's actually read this here. Sleep duration 100 time dot millisecond. Okay. Why am I printing this out? That's the other problem. Interesting. Okay, time dot sleep or time. And second, I guess, is just a unit. Let's see, do I need parentheses? I do not. And let's do after like times 5. 1, 2, 3, 4, 5. Okay, brilliant. These are the types of things, again, that, when they work, you just want them to work on various operating systems. So if the standard library is good and has these types of things, brilliant. So I already like this standard library, what I'm seeing. It's got the Unicode stuff. It looks like it's got some ways to handle a bunch of string functions, which are nice to have here. So I'll probably want to take a look at those. Sorting. Oh, interesting. Loading different plugins. That's going to be kind of neat here if we write some libraries and stuff. That's like DL open or something on C. Slices, I'm sure we'll see this here. DLang's really got clean slices. I'll be curious if Go's stuff that it has. What's this net module? Right, because it's the language for the web. Go is. Okay, so cool. Parsing stuff, looking up strings, or looking up addresses. Okay, TCP stuff. And HTML, cool. Oh, it's even got an image library. Interesting. That is very curious. And that's kind of nice here. If I can just decode a PNG image, that's pretty cool here. So have some common formats. I wonder if I can even read frames from a GIF file. That's pretty cool here. So maybe we can even, that's something missing from like, C++ here. If I have a simple way to just draw and build like little games in Go, that's a game changer when I think about like, what's a great language to teach folks if I have a simple like drawing library that just works. That's brilliant. Okay. Okay, cool. And a database. Yep. Got a SQL and SQL driver here for SQL-like databases. Cool, cool. Okay, let's actually get to the tour here. I'm enjoying this. We'll just keep going as long as I enjoy this, which could be a long time. All right. Oh, I finished the tour here. Okay, I finished the first module. Okay, so every Go thing is made up of a package here. Okay, neat. And then I have the import paths here. Okay, I wonder if there's a way to nest packages. We'll have to see how that is. But by convention, okay, I've got the package name is the same as the last element of the import path. So mathrand, okay, is the prizes files that begin with the statement package rand. Okay, cool. I'll have to mess around with that a little bit, maybe with a larger project. But these imports, that makes sense here. It's a good stat to use the factored import. Okay. Which must be like this. That's just a little bit cleaner here. You don't have to type out import a million times. Nice. Exported names. Okay. And Go name is exported if it begins with a capital letter. Ah, okay. That makes sense why all the library names were capital letters here. Pizza and pie do not start with capital letters. So they're not exported. Okay, interesting. So the actual language has built into it. I mean, these are the types of things like Python, right, is infamous for being a white space language where the indentation matters. But for this, the actual symbol names, just all the stuff that's uppercase is important. So I guess export it. That makes sense. Run the code. Notice the error message. Sure, sure. And then it says, okay, make sure to use uppercase. Okay. Let's go ahead and just run this example here. We've got our math library. And I'm just putting all these examples together. Here, and let's do some things that we learned here. Import a couple of these here. Something like that. Okay. Oops. I got to get used to... Okay, so that works. That's the preferred style here. And then we want math library. And then let's just print out math.py here. And let's make the mistake too that they recommended, math.py. So this is going to say something like, hey, that symbol's undefined. Yep. And then capitalized symbols are what we have. Okay, and then we get pi. Built-in constants, nice. We don't have to define those. That's a good thing for a standard library. Okay. Simple enough stuff. Functions, 0 or more arguments here. We got a trailing return type here. That's sort of why. Why do they look this way? Oh, cool. I like when there's a why, so you understand the method to the madness. And Rob Pike's one of the designers of the language, as I understand. Yeah, why is it different? I wonder if it's so you can parse the language. I mean, some of these changes sometimes are so you can parse the language quicker or more quickly. Oh, this is kind of cool here. And this sort of makes sense here. Interesting. Originally, C's function declarations wrote the types of the arguments outside the parens like this. Ah, interesting. I did not know that. That's some good trivia here. And I wonder if you want to return like more types or something, if it's easier to just put it at the end. Yeah, then C's function pointer syntax gets a little bit wild here. Yeah, that's getting a little bit wild. So in Go, yeah, okay. P pointer to int. Interesting. Okay, so we don't have to read this whole thing here. But I do want to see this because this is something that's new, especially for folks who've been watching my series on like D and C++ and C, right? That you've only seen that style. Okay, so it's just saying that it's clear what the return type is. There's no confusion. Yeah, I agree with that. Left to right style. Here's your inputs, here's your output. Okay, so, or if you're returning a function, yeah, that's kind of clear. Okay, cool. Let's go ahead and continue onwards here. Oops, let's go ahead and get this window back here. On Go. Oh, I've made my windows too big, so they're all resizing weird. Okay, there we are. Okay, so let's go ahead and write a little add function. And these are all good, like, little exercises to do in any language. Func add x, y, Oh, still need my commas here. Returns an int. I can get with the trailing return types. This is something C++ added recently too in modern C++. Return x plus y. And not writing the semicolons is always going to throw me off. So let's just go ahead and add another line here. Print line, add 5 and 7. And let's do go run. And we get 12. Brilliant. Functions. Okay. Oh, interesting. This I like here. This is something I've been wondering in different languages. And this might be actually a really nice use case for why to have the trailing type. I think this reads a little bit more cleanly. So many times I write math functions like this. I mean, or I want to write them like this. And one of the reasons is, one, it's just more concise. I don't have to keep typing it. Two, if I change the type, I only have to change it one time, which I guess, let's see if we have floats here. I wonder, real maybe? Okay, we'll find out. But if I have to change the type here, oh, it looks like it might only have a few different types in Go, but we'll see. It is nice to just, only have one type here. Okay, I'm just playing around with the different types there. I like that. Okay, that I'm sold on for sure. For sure, there's been a lot of thought in this language. Multiple return types. Okay, I was gonna say usually you just return a struct, but here it looks like they have some sort of tuple here. I wonder if that's what they call it. Okay, cool. This is a swap function. Swap x, y. They're gonna be strings, and I'm gonna return the strings here. This is cool. Return yx. Okay. Let's see. I haven't created a new string here. Let's see if I fall on my face here. How do I do this here? Something like this here. Air. Okay. I wonder if these types are like all backwards. Okay, we'll just follow the example. I mean, it's doing the type inference here. I like colon equals. That's from, I remember this from Pascal. So that's probably the right thing to do. Here's our function call, Mike, and I don't know, uppercase Mike here. Let's go ahead and print that out. Okay, so we should get the uppercase Mike first. Oops, I made some mistakes somewhere. Let's see here. Func swap. Let's see how good the error messages are. This is good to make a few mistakes here. Return y comma x here. It's not like that. Undefined x, undefined y. No, I did define them here. Ah, it's this comma here. Okay. So I can't have the type string. There we are. Actually, let's go back. Let's put that back there. I want to see how useful those error messages were. Not enough arguments in call to swap. String, comma, string, unknown type. Okay, that was pretty good. And it's telling me the line at 19 where that happened. Okay. So far, I'm happy with the quality of error messages. Named return values here. Okay. Go's return values may be named. If so, they are treated as variables defined at the top of the function. Interesting. These names should be used to document the meaning of the return values. A return statement without arguments returns the named return values. This is known as a naked return. Naked return statements should only be used in short functions, as with the example shown. They can harm readability in longer functions. Okay, interesting. So here I'm just saying that this is y here. Okay. Interesting. Let's just run this example here. I get 7 and 10 here. Okay. I'll have to think a little bit about that here. Split. What is this function doing? 1 and then 7. Okay, so it's taking in, is there a sum? Oh, I see. So normally we just put a function like int here. If I just use x and y, it's just taking in, the assigned values, and then return doesn't have any type here. Okay, or it's a naked return, rather. It's not specifying the value. That's specified up here. Okay, so you have the type with the like local variables here. Okay, that's kind of neat here. Yeah, it is kind of clean here to just put return. Okay. Neat. Some variables here. Okay, var statement declares a list of variables, as in the function argument list. The type is last. Okay. Var statement can be at the package or function level. Okay, so we'll see both here. Now this time I use the what looks like an assignment operator here. So let's see if that gets decided here. Variables can include initializers. Okay, so we can set the value. And again, it's just sort of going in order. We can do that with multiple of them. The type can be omitted. Okay, if the initializer is present. Okay, it looks like it's just deducing the type pen. That's neat. So if I just have C here, that gets me true. Python, it's false, and Java is no. Let's see. I have to run this one here. 1, 2, true, false, no. Okay. Oh, that's 1, 2. C is true, false, no. Okay, that makes sense. Yeah, after the equal sign is the assignment here. And we're doing multiple things here. That might take a little bit of getting used to, but I like it. I like seeing that ability. Short variable declarations. Okay, the oh, that's a shorthand here. Can be used in place of var declaration with an implicit type. Okay, so it's just guessing the type here. Okay, whereas this is more explicit here. This is a ing or ints, and then we want to initialize them with 1, 2. Okay, pretty nice, pretty nice. I understand it. Go's basic types. Ah, okay, let's see if we have a float. Ah, float 32 and float 64. Okay. And then we have complex numbers built in. Neat. Okay. I've got a byte type, which I like. Yeah, I like having the integer types with the actual width here. Oops, let me move out of the way just so you can see everything for once. But I do like that here. And uint pointer. I wonder if that just takes the system type or whatever it is. But that's pretty clean. Built-in type for a string. Okay, nice. And then a bool here. Nice. Okay. 0 values. Okay, so variables declared without an explicit initial value are given their 0 value. Okay, important for memory safety, right? Making sure that we have some sort of value here assigned rather than garbage. That fixes a lot of C's problems. Some typecasting, type inference, constants. Okay, cool. So I got through the basics. Okay, we've got some for loops. Oh, no parentheses here. That's pretty neat. I wonder if I put them in. Does that break things? Unexpected syntax. It does. Interesting. So this language is really trying to save us from lots of keystrokes, which is great. I think that's fine. Okay, we've got some infinite loops here. Okay. C's while is spelled for in Go. That's gotta be that's a funny joke. Yeah, I've always wondered why have two of the constructs when I mean you can implement them in the same way. A lot of languages, I mean, when they compile this stuff, it compiles down to the same code. This is sort of like lowering one expression to the other. So that's totally fine. You've got a forever loop here. If I imagine they have break statements too. Let's see. Oops, I snuck a semicolon in here. Yeah, program executed. So this is just going to, let's see if this just runs forever. And let's kill it. Okay, so it'll time out. Nice, okay. If statements, again with no, let's see, need not be surrounded by parentheses, but the braces are required. Yes, for the scope here. Let's put those back in. It didn't like it the first time I did it with for loops. Okay, those are fine. Let's see, is that true? So let's go back to our for loop example. For I, and we're going to do assignment for the type 0, I less than 10, I plus plus. Can we do something like that? Again, when you learn these languages, a lot of times it is just wrestling with the syntax here to get started, but the programming concepts you've learned are, you know, all the same. Yeah, so let's see. It just Can we never use the parentheses there? Let's see. Yep, I guess not. Okay. Guess doesn't like it. That's funny. Okay. Let's go ahead and see. Switch statements. Okay. Go only runs a selected case, not all cases that follow. Interesting. So this gets rid of the sort of fall through behavior where if you forget putting a break statement, which is probably what you probably don't want, that fall through statement. I wonder if there's a go to statement in Go. Let's see here. Interesting. So switch evaluation order. Okay, does not call I equals 0. Got it. No conditions. Okay, let's get into some more interesting stuff. Defer. Defers the execution of a function until the surrounding function returns. Interesting. So if I run this, we get hello world in order. This is interesting. This is like in dlang we have scope exit where you can have something run at the end of the scope here. So that's kind of like defer here. So imagine it just builds a stack of those commands. Yep. So if I have two defers, they'll stack up here. Let's run this. And it's going to defer the calls. Yeah, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's a stack. So last in, first out. 9, 8, 7, 6. Yeah, it just runs it in the reverse order here. All right, that's kind of cool here. Now, I wonder if this also allows for lazy evaluation. Like, can I... and again, this is the type of stuff I want folks to comment on. If I have a function call like this, can I do like x defer if this is a function? And do I have to have a return type? I don't think I need one here. Basically, I want to be able to lazily evaluate this function. I wonder if I can do that in Go. Right now, let's just make that like a string. Okay, so I don't have to have the return type. That was fine. But the lazy evaluation might be interesting to see. Okay, we're really flying through this. We've got pointers. Not going to spend too much time on that, but that's cool to see that we have the addresses of things. Structs. Let's build a type. Let's build it. Let's build it and let's try to print it out. Let's see what happens. Type vertex. Okay, so it's a new type declaration. Struct. We'll have an x, y, int. Okay, let's do it on the same line here. Is it like that? Yes. And okay, how do we create a vertex here? V equals vertex. Let's see, I gotta still figure out my variable declarations. Now, how do I do this? Var, right? V vertex, something like that. V's declared and not used. Oh, interesting. Okay. I was scared. I'm still trying to figure out the syntax here. Okay. Okay. So this is like implicit. I see. So these variables are like useful for when you're returning from a function, and the type will be deduced because you already have the type information in swap, right? String. So that's why I don't need the declaration here. Although I wonder if I did put it in here, does that still work? Like am I doing something like that here? I guess I don't need to nest these here. Okay, so that's totally wrong. So anyways, if I do vertex v2, and struggling on just the v2 also declared not used. Vertex type is not an expression. Okay, interesting. All right, let's just do this here. Let's see, how do I access a field here? X equals 5. Okay, that works. V.y equals 9. And let's see if I can just print out arbitrary structures, what happens. Does it format them? Undefined. So I have to spell things right. All right, what did it do here? Well, it ran really fast. Oh, cool. It just prints it out. Cool. So I didn't need to write out any sort of special thing. I mean, it is just a struct here, and it just gives me the fields here. Okay, that's kind of nice here. That's probably super useful when using with like GDB or something, which you know, question, how do I build an executable? So we'll have to figure out some of these things as well. All right, there's our fields. Okay, dot notation. Pointers to structs here. The language just permits us to use dot, even if we have a pointer. Okay, so that's really nice. Very cool here. Okay, so if we have a pointer to this thing here, yep, we can just access it with the dot notation. Struct literals. Okay, these are all nice things to have. Some convenience things for setting up our structs. Arrays. Okay, so I've got arrays. Stack declared. Seems nice. And we've got our slices. Okay. Oh, this is getting a little bit interesting here. An array has a fixed size. Okay. Slice, on the other hand, is a dynamically sliced, flexible view into the elements. Okay, this is just like pretty similar to dlang, which I've been doing here. And we can just specify the indices. Yep, I like having slices in languages. That's really nice. So let's go ahead and let's play around with these a little bit here. Okay, so let's just go ahead and create a var s here. So this is going to be integers. Okay, here's our primes. Okay, and okay, let's just change it up a little bit to odds. Let's have 5 of them. So 1, 3, 5, 7, 9. And our slice is just going to be, so let's write that out here. Slice of integers, and that's going to be equal to the odds, if I can spell that right. And let's go ahead and do like 2 to 4. And then let's go ahead and print it out. Print out our slice. Cool. Let's run it. Take a peek here. And here's our slice in the brackets here. Okay, 5 and 7. Okay, pretty clean stuff here. Now slices, I haven't looked. I know Go is a garbage collected language, so I'm assuming it's just going to fix those things for us. I know recently Go, and thanks for listening. If you're listening this far in, make a comment about it. So you watch me learn the Go programming language. But I think there are arenas coming or experimental in the Go programming language now, which is kind of neat. So, there's probably some efficient things that we can do with actually allocating memory that we want to be long-lived and these types of things. Now we kind of have to start thinking about this when we think about like dynamically sized and automatically created data structures here. So yeah, slices are basically references to arrays, and I'm assuming it's going to keep that slice or that array alive as long as there's a reference to it. Okay, cool. And let's see how we get some of the properties here. If they're just function calls, let's see here. Oh, I like this, that things aren't in order. That's the first time we've seen that. Oh, and we're extending the length here. Interesting. Slice the slice to give it 0 length. Okay. So there's some syntax here for doing some like shortcuts, which is nice. Drop its first 2 values. Okay, so neat stuff here. Empty slices. And okay, let's make here. That's creating the dynamically sized slice here. Okay, which I imagine this is just a heap allocated array or something. Okay, so we got a bunch of this stuff. Let's go to ranges. This is neat here. Make for I. Okay, this is getting into something powerful. Okay, so we're making 10 integers, and then for I, we're creating a range here based off of this power function here. So that's going to be zeros all the way in. I'm assuming this is 0 initializing this particular array here, and then it's multiplying each of these. I'll have to really think about what this is doing. If you want only the index, let's see. Let's go back here. Range, form of the for loop iterates over a slice or a map. Two values are returned for each iteration. The first is the index and the second is a copy of the... I see. So yeah, range-based loop, you have the index and then the actual value here. Okay, should have started with this example. So this is just printing out everything, and then based off the index, which is the first thing, that's what it's printing off. Okay, so it makes sense that here we just have the index that's 10 elements here, going to print out things. Okay, cool. And there's some shorthand. Okay, and then we've got built-in maps. Okay, yeah, I think every modern programming language these days probably needs like a map data structure built in and a slice. That's probably a good idea. So yep, here's our map. I wonder if it's unordered or ordered. Those are some other things to wonder about. Map literals, that's cool. So we can, they're like struct literals. Okay, keys of course are required. Makes sense. Yeah, this is interesting stuff. This is the kind of stuff too I get interested in some languages like D, where you can construct these at compile time. And that can be super efficient. So yeah, let's see, mutating maps. Yep, just updating them. Cool. And again, if we use that make, that looks like it's heap allocating. I wonder if these maps are always heap allocated reference types. Although if we've got literals, this means they're like not resizable, I'm assuming. So if I try, let's see, my map is M, and what were we doing? Google. Let's try to change it. Let's see, how do we change things here in the structure? With a vertex, okay, equals some new thing. Here, let's just take this one. And now we're going to try to change Bell Labs. Oh, I guess. Well, we didn't mutate it, so it didn't change. 50. Let's see if it complains about that, because I'm using a type that's not a... oh, I am. 50 is okay, but it might need to be 50.0 or something. Yeah, okay, I guess we can still mutate that map here. But what if we put alphabet in here? Will it add? Okay, it is adding. Okay. I thought this would be like a static or non-sizing type here, but I guess it is always, must always be heap allocated, and then you can change it. Okay, cool, cool. Word count, interesting here. Just return a map here. Okay, so this is just another package here that runs a test suite against the provided functions. Okay, cool. Oh, it failed. Something failed here. All right, closures. Okay, so we can write functions that return functions. Okay, so that's kind of cool. And it can reference stuff outside of its body. Sure. Okay. Yep, that's a closure. All right, let's get into some other stuff. Methods. Go does not have classes, however, you can define methods on types. Okay, that's like the basic minimum thing that you'd need for an object-oriented style programming here. Let's see, how are they doing that here? The method is a function with a special receiver argument. Okay, the receiver appears in its own argument list between the func keyword and the methods. Ah, interesting. Okay, so that's just here. In this example, ab's method has a receiver of type vertex v. Okay. Yeah, that's kind of interesting. Interesting structure here. I mean, this is effectively what, when you have a struct anyways in a programming language that is, how do I say, object oriented, right? It's just passing a hidden this pointer. Yeah, so this is kind of neat here. Neat way to do this. It's clean enough. It separates out, I guess, the structure, and then you just have the functions after it. Okay, simple enough. I like that it doesn't clutter too much when you embed the type here, that it is its separate thing, so I'm fine with that. Methods are functions with a receiver argument. Okay. Yep, we know that. Methods continued. Let's see, you can define a method with a receiver whose type is defined in the same package. Or in another package. Okay, so you can split these up here. Here's the sort of type, how to say, let's go ahead and run this definition here. Pointer receivers. Okay, try removing the star from the declaration of the scale function and observe how the program's behavior changes. Okay, let's try this one out. So you can declare a method with pointer receivers. Receiver type has a literal syntax as well. Okay. Methods with pointer receivers can modify the value to which the receiver points, as scale does here. Okay, so let's try to run it here. We've got the pointer here. We've got our vertex. We set scale to 10. And then we print out the absolute value here, which is squaring these components here. And then we're scaling it. Okay. That's saying get rid of this on scale and then try it out here. And it gives us 5 back. Okay. Yeah, so it is actually modifying it. Well, let's see that again here. What is scale doing here, actually? Oh, it's multiplying. So this is 30 and 40. I see. Let's see. Yeah, so this is basically how we get pass by reference. I should say it's always pass by value, but when we have the pointer, we're actually modifying this versus not. Okay. I see. So the other way to think about this too, okay, yeah, that makes sense. Pointers and values. Okay, so yeah, this is just stuff about modifying the actual value here. I mean, this is just showing us how to do object-oriented programming without the receiver function here. Syntax, although again, I could be wrong about that. Choosing a value or pointer receiver. That was my next question here. 2 reasons to use a pointer receiver. Okay, so you can modify the value it points to and to avoid copying the value. Okay, that's why we do it. Versus a function. And we don't want to mix these. Okay, that makes sense. All methods of a given type should have either value or pointer receiver. Okay, fair enough. Okay, we've got interfaces that we can program to. That's cool. Interface keyword. And let's see here. Do we have a type here that we program to this interface? That's the question here. Float implements this. Okay. My float, that's just some type. Okay. Cannot use v. Uh-oh, this example is actually not working here. Because there's an error. Vertex value doesn't implement the absoluter function here. Okay, that's kind of cool. Good way to enforce interfaces. Okay. I'm gonna skip through some of this stuff here. Let's, because this video is getting kind of long. But I'm enjoying this here. Stringer. Okay. Let's see what this is doing here. Let's see. Most ubiquitous interfaces is a stringer defined by the format package. Okay. Stringer is a type that can describe itself as a string. Okay. So I've got this type with a name and an integer here, and I want to basically make this into some sort of string here. I've got a person, and I want to be able to print this. Okay. String with the parentheses is the stringer interface here. Okay, cool. I wonder if all the structs and stuff work with this interface so they could just print things out. That's cool. Errors. Okay, we can return nil values. Go programs express error state with error values. Okay. All right, cool. Let's get into a few of the other interesting things here. Let's try this one with the image here. I'm actually really curious about this. Okay, this is just creating a new image. It's got a format here, RGBA. I wonder how many different formats there are. There's all sorts of other ones like YUV and all those kind of things too. Images. Let's run this here. This one I might have to run locally here. Let's Let's try this out here since we haven't coded in a while. Let's just delete everything. Paste this in. No module. Okay, so go git golang.org. I like this here. Good package management here, telling me what I messed up and making it trivial. Run it. Okay, but image does not implement this thing here. Okay. How do we do that then? Remember the picture generator you wrote earlier? Let's write another one. Define your own image type. Oh, okay, I have to actually do something here. That's okay, I can just display an image. Okay. Here's our like interface here. Okay, let's define your own image type. Implement the necessary methods and call pic.showImage. Okay, this is giving us actual exercise. Maybe we'll do that later. Generic types. Okay, any, I guess, is the type here for a generic thing. That's kind of neat. I think generics were a newer thing, if I recall, added to Go, which are super... I think they're useful when you have a container data type, for instance. So that can be useful. Comparable. Okay, let's use equals and stuff. Okay. All right. Go routines. Okay, let's at least get through this here because I think this is the main like show here. If I say go. All right, let's actually run this example here. Our image example didn't work, but that'll be cool when it does work. Here, let's get rid of this again, and let's paste in our go routine here and take a look at this. Hello world, hello. Okay, so there's no synchronization here, but we are creating or calling this function here. And this is basically a fiber or a thread, and just calling this 5 times here. Okay, and we say world. Interesting. And how do we, and we say hello 5 times as well? Interesting. Writing out this string. Okay. Let's try to understand this code a little bit. Go. Again, is a lightweight thread. Okay. And this is really one of the key features of Go, being able to launch these guys really easily. Let's see, the evaluation of f of these functions x, y, and z happens in the current Go routine. Execution of f happens in the new Go routine. Okay, interesting. Go routines run in the same address space, so access to shared memory must be synchronized. Okay, so we might need a lock or something. The sync package provides useful primitives, although you won't need them much. Okay, that's good to know here. So let's see, I said go. Oh, I see. Right, so I ran this function basically without synchronization, and then the other one that's just printing hello. Okay, so one's running in the main thread and the other one's running. I see, got it. Okay, let's see here. Let's do some other stuff. So channels are typed conduits through which you can send and receive values with the channel operator. Okay, so this must be some sort of message passing interface here. Send v to ch. Okay, receive from ch and assign to the value v. Okay, interesting. Channels must be created before their use. Send and receive until the other side's ready. Yeah, this is some nice trick here. This allows Go routines to synchronize without explicit locks or conditional variables. Yeah, everything's synchronized here. Maybe it has a monitor, or maybe this is just some message passing thing, but let's go ahead and run this. So I've got this set of numbers here. I make this channel here, and then I'm summing up the first half and then the second half. What is my sum doing? Oh, it's taking the channel here. Interesting. And let's see. It's I didn't really understand the range syntax. I needed to spend some more time with that. But kind of putting things together here. Interesting. Okay. This is pretty cool here. Having like a message passing, again, I've done a little bit of this in the dlang, which has message passing. And let me see if that's the right thing to call this. If I should be calling it message passing here, because that's what it looks like to me on initial investigation here. But that looks, that's pretty powerful, and it's really a great thing for eliminating a lot of different concurrency error messages. Erlang's another great language that has this sort of actor model for doing concurrent programming. So I wonder if Go was inspired by that as it was being developed here. Okay, cool. So I'm going to kind of fly through this. This has been a great tour as far as different things that can be done here. I like these select blocks. Okay, that's pretty cool here with a case statement. Yeah, it looks like, I mean, again, this thing is built for like distributed systems here. Okay, cool. We're going to do some sort of equivalent thing here. We've got locks here. What if we don't need communication? Okay. Yeah, mutual exclusion. Try to avoid locks if possible, but there you go. Okay, cool. A little web crawler here. Awesome. Wow, that's pretty good. This video is longer than I expected. I got really into this here. And it looks like there's some nice tutorials. There's some really nice infrastructure here. I like this concurrency patterns stuff here. We'll have to look at this. Oh, these are some YouTube talks here. Okay. That'll be great to take a look at later on here. But overall, you know, I'm really impressed with the documentation. The tour is great. Really seems to be a powerful language here. You know, you give me these features, you give me structs, slices, maps, these types of things. You know, those are the basic primitives I need for programming basically everything. I'd be really curious to use Go for, you know, some game programming stuff and to play around with it on a server or something. The concurrency is certainly powerful, and that the fact that it's a first-class citizen in the language, it's built in right with a Go routine and channels and stuff. That's really nice. You know, these are some things that dlang has. Dlang's a much larger language, and of course C++ has some of these things through libraries. But I really like the compactness of this language. Seems like it's really well thought out, and it feels like I could probably learn this in a few days or weeks as far as some of the basic syntax. I mean, you saw me messing around and struggling with like initializing the variables, but I'll probably understand that in like 5 more minutes of practice. And the ranges and stuff. Might be interesting to play around with building data structures. I like how the tutorial had like building a little binary tree in there, because that's a nice thing to know how to do, or, you know, building heaps or a graph or something are all good exercises to do when learning a language. I don't know how to rate these things, but again, I was really happy with the standard library. This web page is really clean. I'll be interested in seeing the community. I like that they have, you know, a lot of the talks and stuff from the conferences organized. So that's very good. And it just seems like a nice language where you feel like you can have some sort of mastery of it. And again, if I'm probably writing a backend tool or something, I'll probably look a bit closer at Go for that. I'm also curious about using Go for mobile development. I'd be really interested to hear your folks' thoughts on using Go for mobile application development. I know it's Google's language. That doesn't necessarily mean, you know, later on in this series, maybe we'll look at Kotlin, which I know is sort of built for these things, but I'd be curious if you can just kind of do it all in one language here and take a look here. So there you have it, folks. I hope you enjoyed this tour of Go. You know, I kind of, me fumbling around through the tour, but just kind of talking about it in terms of other languages I know, trying some examples. I was quite impressed from a first impression. This is my first hour in Go. You should probably do the same thing looking at the tour if you're trying to learn this. Let me know in the comments what your thoughts are on mobile development or using this as a backend tool. I'll be really curious to hear that. And otherwise, in the comments below, let me know if there's a programming language I haven't covered on my channel that you want me to do a first impression. I've got a few that I'm going to be trying out anyway, so keep an eye out for those. But otherwise, hopefully you enjoyed this. And as always, folks, thanks for your time and attention. And if you made it to the end, let me know in the comments. I appreciate that. And you have great patience. Hopefully you're able to follow along. Anyways, folks, take care, and I look forward to seeing you in the next video.